Hello class, so today we're going to go ahead and continue. So we're going to go ahead and practice the remainder theorem. So that's pretty much telling me that I can go ahead and check if the given linear term x minus k is a factor. So we can often see that this is a part that's being divided by. Let's go ahead and practice with this one right here, number 4. And it's telling us that x plus 2 could be a factor. Well, we can go ahead and check that by getting our x plus 2, and we can go ahead and x plus 2, we make it equal 0 because we need to go ahead and find this x minus k that exists inside this part. So in order to solve that, we set it up x plus 2 equals 0, solve for x is equal to negative 2. Awesome. So what the theorem says, that if I evaluate the function at the given k that I found, this negative 2, I can go ahead and find out if it's a factor or not. All I have to do is determine if the function as remainder is 0. Okay, minus 5x plus positive 6. So I'm going to go ahead and write the equation again, but instead of writing x's, I'm going to go ahead and replace it with this negative 2. So parentheses cubic minus parentheses squared minus 5 parentheses plus 6. Inside those parentheses, I'm going to put this k value that I found, which is a negative 2. So negative 2, negative 2, negative 2. Then I simplify. Okay, I have a negative to a third degree, so that's negative times negative times negative, that is negative, and then 2 times 2 times 2, that is 8. I go ahead and continue. I got a negative 2 squared, so therefore that's negative 2 times negative 2, that is a 4, but on the outside it's being multiplied by this negative 2, so that is another negative 8. So I've taken care of all of this so far. Now here we got a negative times a negative, that is a positive. 5 times 2, that is a 10. Then I have a plus 6. So I got negative 16 plus 16, which gives me a remainder of 0. So what this tells me is that when x equals negative 2, this is a factor. I can go ahead and rewrite this into be a linear factor of the function, but all I have to do is get this negative 2, and I have to go ahead and move it to the same side over here to the x. So all I have to do is a little bit of algebra, add 2, add 2. It gives me x plus 2 as one of the factors. This works because the remainder is 0. Let's go ahead and do this the same way over here, and we can go ahead and see, let's do this one. Number 6, the same idea occurs. We have here x plus 1 could be a factor, we don't know that, but we can use the remainder theorem. So we set this equal to 0 that I got from over here. That gives me that x is negative 1. Now, according to the theorem, I can go ahead and evaluate this entire function with this negative 1, and I need to go ahead and substitute into the equation. So the equation is x cubed, but now I'm going to go ahead and write it with parentheses, so it's parentheses cubic minus 7 parentheses minus 6, and inside those parentheses I put the negative 1, and I go ahead and continue. So negative to the third power, that's still negative. 1 to the third is still 1. Negative, negative, that is plus 7 minus this over here, 6. I go ahead and combine like terms. Negative 7 plus 7 equals 0. So x plus 1 is a factor because our remainder is 0. Awesome. So that was a quick little way of how to check if these linear factors are being divided with synthetic or long divisions are factors. Awesome.